My name is Alexander. I represent Toloka AI, and let me first introduce our company, the work that we do for our clients. Toloka is a data partner. We work with model producers and companies that apply Gen AI for the use cases. We produce data for post-training stages mostly, fine-tuning RLHF, and what is the most relevant for the safety track, safety evaluations, and we do red teaming services. We do it mostly using human work. We have a large pool of data workers, varying from the general crowd who could perform the simple annotation tasks to the highly specialized domain experts, linguistics, coding, law, you name it. And we have done this for more than 10 years. We started as a data annotation solution for the classical machine learning and recently moved almost exclusively to providing services for Gen AI. We have built the technology and the set of processes that allows us to produce the high quality data at scale, and we leverage that to do also some safety work. And the main safety projects that we build, that we do, is working with sensitive data annotation. We do complex classifications, granular annotation of sensitive categories, safety evaluation data sets, and red teaming. And what I wanted to do today is to share what challenges we see while producing such data, since I think many of those would be relevant for the companies who are building the evaluation data sets, getting data for it. So I'll start with a little bit of an overview how we approach designing the evaluation, and then I will go into 3 different case studies highlighting the specific and practical challenges that we see. So first, starting from the overall safety evaluation problem is not solved as a problem in the industry. There is a lot of research being done, a lot of papers are being published every month. Products and services, including ours, are being developed, but since we push the models into production and we really want to get them to the use cases, so the safety is always a little bit lagging, and also the model capabilities emerge, so we always have to catch up with covering all the aspects of safety. And one of the reasons is because it is complex. So the threat can come in different directions. We have to protect our users from the malicious use. We have to protect the products of potential malicious actors. We have to prevent the malicious use of our products, regulations being developed, and the capabilities emerge. So there is a very useful source, it's called the AI incident database, that records what real-life incidents has already happened. And what I find useful is to think through some of the examples that already happened in real life and think what kind of evaluations should have been done before in order for the companies to prevent such. And some of those are relatively straightforward. Recent example, a consumer app. They were developing the year-end summaries, like the one you would get, like the summary of the music you listen, summary of the food you got. This one was related to the books. It was a summary of the books users read. And one of the users received a summary automatically generated, which contained really inappropriate remarks about the set of authors and the racial race of authors of the books that we read. And this example, it's quite straightforward to catch such summary at the evaluation stage, but in order to build the evaluation data set, one would need to create a custom data set of the different variations of the books, put them together, and this would be a work that you wouldn't find like in the papers. And some other incidents would be even less straightforward. If you think of claims of LLMs being used to plan terrorism attack, or claims of users developing emotional connection with the chats, it is harder to even design the evaluation like this. So That's one of the reasons why the companies end up developing their own custom evaluations. And let's go through the big main steps that one needs to do that. We always start with identifying the specific risk. What is the risk of the use case? And we define the five types of those, varying from endorsing harmful conversation, where the set of prompts would need to test the model to just engage into the conversation, to the more complex one as the evaluation of availability of the restricted information would likely require experts to first list such restricted information, and therefore building the data set will be a more complex problem. And the next question would be how to actually get such data. And open data sets would be a good starting point, but in most of the real situations, they would miss the domain specificity for the specific use case. They might not be available in the required language, and the coverage of text-to-text is much higher compared to multimodal evaluations, to agentic, and so on. Having that in mind, I want to bring up the examples. And I have three, starting with text-to-text evaluations. The first example is a project that we have done for ML Commons. For those who doesn't know, this is an open engineering community, which mission is to develop the industry standards and creating the standards for evaluation. Last year, they have released AI Illuminate benchmark, and we were one of the vendors creating prompts for such benchmark. I'll give you a brief overview of the structure of the dataset. The objective is to measure the general purpose chat-like model of safety, creating the safety baseline. So those are relatively simple prompts, varying from the safe to straightforward dangerous questions. So the model would need to score 99.9% of such benchmark to be considered excellent. 24,000 prompts covering 12 categories, 8 weapons, violence, specialized advice, and so on. Roughly 2,000 prompts per category. Varying from safe to dangerous. Relatively short, 1 or 2 sentences. We've done it in 2 languages. And once you need to create data for such data set, there are 3 things I want to point out here. Is how to create diversity of the samples, how to actually get the high quality plots, and to control and scale this quality, and actually how to deal with translation and localization of one of the test samples into the other languages. So points 2 and 3, we approach by building a pipeline. We treat data production as a pipeline, which starts all the way from sourcing people, evaluating performers, and then having metrics on each stage, both at the level of the prompts and the level of performers, controlling the quality, onboarding, and then creating loops, redoing, rejecting the test samples, such delivery, ending up with the final data set. And the diversity aspect, this is what I want to spend a bit more time on. If we think about producing like 2,000 prompts within the given category, we always approach it as a kind of 2 dimensions. One dimension being the topic, and another dimension would be all the different types of questions that we would like to test for. Yeah. The categories is about decomposition. We always start with some taxonomy. There are standard taxonomies available. We have our own starting point. Many companies will have their own. Then we would decompose it into the required level of granularity. Typically, we would do like a set of categories, subcategories, sub-subcategories, having dozens of items on each stage, thus going down, say, from the overall danger to a more specific types of activities, going down to physical stunts, and ending up with the specific topic that we want to uncover.
When we take the specific topic, we unpack the user intent. Here we always start with the overall user persona. We create the prompts kind of by safe user. This would be not the random kind of questions, but more the questions provoking the model for over deflection, creating borderline situations, but the question is benign, even though the area is potentially dangerous. We would move into clearly malicious users, asking clearly malicious questions, and then to the users that use some of the adversarial techniques. And starting from that, you would create a libraries of techniques, introducing the diversity of the types of questions and if needed for linguistics and so on. In this fashion, we can end up with a diverse set of questions, ensure there are no duplicates, and actually have a control of what we're testing for. The second example is the multimodaling. This is another project. We've done the red teaming test of before the release of the video generation model. It's done over a course of 3 weeks. 3,000 tests, and we have done assessment from broad range of policies, 30 plus policies, including safety, biases, some privacy, some security risks. And there are 3 things I wanted to highlight here. One is actually technical challenges. Within the given time, within the short time frame, there might be problems with model availability. Model can be up and down. In case of video generation, the actual generation might take time, up to a couple of minutes. Therefore, we don't have a luxury of synthetically generating like 30,000 samples, sending them to the model, and then analyzing the results. In this situation, we would move like in the short iterations, creating a small testing samples and selecting the next batch based on the previous results. We would start with creating a baseline, sending safe prompts and some clearly dangerous requests to the model. So we would immediately see the level of over deflection, since it's not hard to make a model harmless, but we always have this trade-off with helpfulness. And in some situations, you can see up to like 40% of over deflection rate when the filters are really tight.
And even straightforward questions would still produce some violations. Like for example, those could be some unusual types of weapons that the model didn't catch. Or in case of video generation, actually the harm can be introduced even if it was not implied by the prompt. So the model can get a context in which, I don't know, if you take an example of a sports bar and people being expressive, it may add alcohol even though your policy might not allow for it, or they can get into fights, and you need to test those. And then we would, based on those results, we would decide which areas we want to test further and to test more sophisticated techniques. And third observation, which is relevant for multimodality, is the evaluation. So automated evaluation is possible. In case of text-to-text, many companies would opt for automated evaluation of the responses. For video evaluation, there are automated solutions. Typically, they work frame by frame. But if you want to achieve a really granular assessment, you may want to have humans to evaluate the overall safety, such as model may not catch the texts which make sense in the video, but are not easily identifiable on the given frame, and many situations would require subjective human judgment. And the third example would be agents. We will be working, all of us, I think, over the next years more and more with agents. And let's take computer use agent as an example. Let's first unpack what the computer use agent does. So the user will create a prompt. Agent would have a set of tools controlling, let's say, a virtual machine. This virtual machine would have the environment configuration. There are files that are available on a desktop. Agent may interact with the websites. And if we think about the data structure, if we think about this as data, it is very different. So we have the user prompt, we have the unique configuration of the environment, then we would have the trajectory of an agent that goes through this environment creating actions, and we would need to evaluate those actions as well as the final outcome. Let's say you have an email scenario, like user asks agent to analyze an email, and you would have a phishing email. If before we had the phishing emails phishing humans to do something not safe, in these situations they might be phishing for agents users. And these prompt injections may result in download of malicious file or responding to the email with some personal information. So even taxonomy of building such evaluation is much more complex. We need to unpack all the surfaces of a potential prompt injection. If we take an example of a safe user request and the dangerous agent behavior via prompt injections, we would need to think through all the surfaces within the web, within the files, within the applications that are being used. We would need to inject prompts in the different places and then play all the combinations of the user request, initial configuration, and how the agent performs within the same environment, whereas agent actually might change the trajectory. It might not be too deterministic. So taxonomy is new, and this area is much less covered by the research at the moment, so a lot of this needs to be created for the specific use case on the go. And the second challenge would be the technical implementation, as you can start with testing the agents in an online manner, like publishing the websites online and checking for them. But if you want to create a data set that you will use on a recurring basis, or maybe even for training, you may end up developing kind of the offline tests, the offline versions of such tests with mock websites and building the automated evaluation of those. So very challenging, very interesting, and it will get more and more complex with every new release of the technology. That was everything I wanted to share. We are happy to help with any of such challenges, and I would be happy to learn more about your specific situations or the problems you faced after this talk. Thank you.